All right, since I've been out for a bunch of days to have my surgery, I thought that while I was recovering, I would create some little video tutorials to go over fractions because they are such an important part of what we need to know in fifth grade. Okay, so we're going to start with adding fractions. You'll remember that adding of fractions is done in two different ways, depending on whether the fractions you are adding have like denominators, which is the bottom number, or unlike denominators. You remember numerator is the top number, the denominator is the bottom number. And before we talk about this, we need to remember that the bottom number tells us how many parts we've cut our whole into. So for example, if the bottom number, the denominator of a fraction, is 4, it tells you that we took a whole, in this case, let's call it a, sheet of paper, and we cut it into 4 separate parts. If the denominator were to be 8, we would have cut the sheet into 8 equal parts, and so on. And you remember that the numerator tells us how many of those parts we're actually interested in and we're working with. So if we have 2/3, we have something that we've cut into 3 parts and we're interested in working with 2 of those parts. Okay, with that said, when you have like denominators, really easy. Okay, so if you have like 2/3 plus 1/3, piece of cake. You just add the numerators and keep the same denominator. That's it. Just carry it across. Don't change the denominator. The denominator stays the same. Okay. Then it becomes a lot more tricky when we are talking about adding fractions with unlike denominators. This is where you have to remember that you have to make equivalent fractions, which are fractions that have the same value as the fraction you started with, but you have to make the fractions so that the fractions in your problem, in this case 2/3 and 1/5, both have the same denominator. And you'll recall that there are several ways to do this. If you go back through my various videos from Math Antics and others, you will see different ways, but I'm just going to show you what one teacher from Australia calls the boom, boom, pow method. And that is, I call it cross multiplication. This is how I learned to do it, is you multiply this way, you multiply this way, and you multiply this way. Boom, this way, boom, this way, and pow, right here, multiply this way. So we start out, we say 2 times 5 is 10, 3 times 1 is 3, 3 times 5 is 15. And now we can ignore all of this stuff and just add, oops, sorry about that, that should be a 15. And we just add, as we would, any fractions with the same denominator, because now we have the 15 here, we have 15 here, and so we just bring the 15 over, and we add the 2 numerators, and we get 13/15. Now don't forget this last step. You have to look and see if that can be reduced to a simpler form. If it can, you have to reduce it to its simplest form. If it can't be, as in this case, because you have 13 here, which is a prime number, you can't divide 13 by anything but itself and 1, you're going to leave it as it is. Okay? So that's the way we do it. Let's just do one more example of each. 3/5 plus 1/5 equals 4/5. We just added the 2 numerators and kept the same denominator. But if we have 3/5 plus 1/2, the method that I'm going to use is my cross multiplication. I'm going to go 2 times 3 is 6. I'm going to go 5 times 1 is 5. And I'm going to say 5 times 2 is 10. And I'm going to now very easily say it's 10. And 6 plus 5 is 11. So this is something that has to be simplified. And you'll remember that this, because it's a top-heavy fraction, the value of the number in the numerator slot is bigger than the one in the denominator. This is an improper fraction. So we need to say to ourselves, how many times does 10 go into 11? It goes 1 time, and it leaves 1/10 left over. So our answer would be 1 1/10. Okay, I hope that helps. Please, please, please make sure you understand how to do this. This will be on the test. This will be constantly. I'm going to remind you about the importance of knowing all the basics of fractions. Okay, thanks.